Hi everyone, and welcome to our webinar today on how to design campus networks. My name is Kelly. I work in marketing here at IBWave, and I will be moderating the webinar. Before we get started, I just have a few housekeeping items to go over with you. We will be recording the webinar today, so everyone will receive a recording of it after the webinar. We encourage you to please ask questions as we go, and we'll try to get to them at the end. We've left some time for that. You can use the question box in your go-to webinar panel. And now I'm going to introduce our speaker. I call him Robin Campus Networks Mitchell because he has become the IBWave residential guru in all things campus networks. And he is definitely the best person to be hearing from today on how to tackle the challenges of designing campus networks. So welcome to you, Robin. Thanks very much for being here and to presenting. And at this point, I'm going to hand it over to you.
Thanks, Kelly. I'm glad to be here and be able to present today. I'm excited about what we're going to show today because it's definitely going to help those who are working on deploying a campus network, whether it's their first time and getting started, or hopefully if they've done this before and they're an expert at it, it will be good information for them to develop their skill set in order to be able to design better campus networks. So there are 5 key challenges that we'll focus on today. 1, accessing geodata and the challenges that come with that. A lot of times we think about geodata as not being as important from those who have been designing macro networks from a general sense early on, but as technology develops and higher frequencies, the geodata becomes more and more important, and we'll dive into that. Then we'll get into the impact of the indoor RF propagations on the outdoor environment and vice versa. Both networks have a symbiotic relationship, and they both impact one another. So definitely being able to understand that will help you in your campus design. And then making sure you're aware of traffic trends and the key performance indicators that tell you what's going on with your network definitely will help you better understand the direction you need to go as you develop your campus design. And then 4th, we'll deal with the node count and placement. There's some very unique challenges when it comes to placing nodes on a campus, and some of the different aesthetics and arrangements that need to be considered when it comes to your node placement definitely will impact your design. And then finally, focusing on sector seams and handoffs, and then we'll get into some campus designs and different nuances and look at solutions to help you address those needs. So let's dive into the geodata and the challenges that we'll face with the geodata. Now, definitely, geodata is becoming a more common term, but for those who aren't familiar with the term geodata, geodata is also known as geographic data or geospatial data. And this data is referred to information that has explicit or implicit association with a location relative to the Earth's surface. Now, good geodata is critical for 5G designs, which relies on current high-resolution maps to deliver valuable context for informed, data-driven decision-making. So with next-generation 5G geodata, it helps optimize 5G network design by identifying obstructions that may interfere with 5G's highly sensitive signal propagation. Of course, we're talking about the sub-6 gigahertz and millimeter wave frequencies. Now, gathering and analyzing advanced geodata for 5G networks requires the use of 3D geodata mapping software, which provides highly accurate observations to meet the demands of 5G signal sensitivity caused by this frequency features inherent with sub-6 gigahertz and millimeter wave for 5G bands. Now, 3G geodata for telecom requires a platform from which telecommunication network operators, engineers, and data scientists can analyze and visualize complex data records at scale for accurate campus designs. So when it comes to those main layers, those RF propagation impacting layers, you're dealing with terrain heights, clutter, even clutter heights, and not to mention clutter HD or high definition clutter, where it addresses clutter classes based on average height ranges. But what's even more critical is 3D buildings and trees, or polygons that represent the different structures that will impact that signal strength. Now, of course, I came up early on in the age of CDMA back in 1995, where CDMA was just hitting the scene. So I've seen everything from the transition from amps to inamps to CDMA to LTE and now 5G and the like. And so the focus on the signal impact has really grown to focus on those particular layers. Initially, we focused on non-propagational impactful layers like railroads and streets and borders and such, and even satellite imagery when it finally came about. But now those things are even more impactful to be aware of those areas and the geodata associated with those areas in your campus design. As you get to that granular level for 5G analysis for in-building penetration versus that not only penetration in the building, but out of the building. And so what becomes the next question to ask is, well, how do I get this geodata? And is there any free geodata? Or what about how expensive is geodata? Well, you can get into hundreds of thousands of dollars when you look at global geodata. But thankfully, when you're talking about a campus, you're only looking at a couple of square meters, or kilometers rather, a couple of square kilometers, or at the most 5 square kilometers for your campus. And those are bite-sized chunks that are much more affordable and easily digestible. So not so much as expensive it would be to have geodata for the entire country or state. Now, there is free geodata, and you can scour the extents of the internet to come across this free geodata. And well, like the old adage says, you get what you pay for. So even though it's free, it may not have the level of detail required for your campus analysis. So is it really worth it to scour the extents of the internet to find this free geodata? And when I do find it, will it be a benefit? Well, we'll take a look at a case where you may consider free geodata being a bonus and take advantage of that for your campus design. And so we'll dive into the detail of that as we get into our examples. But next, not only accessing the geodata required for your campus design, but also being able to understand the impact of the macro network on your in-building design. The question is, what buildings really need an IDAS or in-building DAS or distributed antenna system? What buildings require it and to what extent? And being able to determine how much of that macro network is coming inside the building. Where your antenna small cells will be placed inside the building. And without knowing how much of that macro environment will engross or encompass or approach the in-building system, you can be designing blind, and in some cases over design or under design your in-building system. Under designing would be when you don't know the impact of that macro system inside your building. You place your coverage antennas or small cells throughout the building in key areas where you know your users are, or where your key users may have complained about, and you place those antennas there. But then once the system is deployed, because of that macro environment still coming in certain areas, or entryways, windows, or areas that you have not investigated, you could end up having a handoff issue or poor call quality or poor throughput because you have not you have under designed your network. And of course, over designing is you've got so much coverage throughout your facility that you're covering outside the facility, and that is impacting your macro network. And when that happens, you will definitely impact your handoffs, ingress and egress for that building. And not only that, you can impact the capacity plans for that in-building system. You may not have planned to cover part of the outdoor and pick up additional users, and that will definitely shrink the coverage that you would have had inside the building. And once again, you're back into a challenge for making sure you have quality calls and throughput inside the building. And then the dreaded neighbor list. Why is that dreaded? If you are covering outside the building, or you have macro sites serving inside the building, and you have not made accommodations for those neighbors in your neighbor list, then you will have missing neighbors and will drag a call further than you had intended, or decrease the coverage that you would have expected to have simply because their handoffs are not taking place. So there are definitely challenges that are become apparent when you are not aware of the macro coverage inside the building, and vice versa, the in-buildings coverage outside the building. And having this awareness will make you a better designer and improve the speed of deployment, because you definitely want to know these challenges before the system is deployed. If you see these impacts after the system is deployed, of course, it is more costly and more time consuming and ultimately impactful for your customers. Now, traffic trends will definitely help dictate or identify your areas for the most need for your in-building system, and maybe even ODAS for your campus environment. So that outdoor DAS will be identified by using your network's key performance indicators and working with your traffic engineering team to determine where your traffic is located. Now, traditionally, you would mostly be concerned about coverage. Where do we have coverage? Where do we not have coverage? But that old adage that we used to say in RF design engineering, if you build it, they will come, is no longer applicable. They're already there. They're just waiting on you to build it. So your capacity, or pent up capacity, is waiting for you to build that campus design or that campus network. And of course, you're really dealing with both, not just a coverage concern, but a capacity concern. And then when you're talking about traffic trends, is the traffic transient? You're talking about street level traffic where speeds are 35 miles and up, or are you talking about pedestrian traffic on a campus environment where you're not so concerned about the speed of the traffic, but more so about the stagnant or clustering of traffic? And so being able to know where those areas are will be extremely helpful when you are designing the placement of your outdoor nodes for your campus. And then key performance indicators, or KPIs, will point out your priorities, where your highest areas of block calls or ineffective attempts, where are your drop calls taking place, how does your quality look when you look at your RSRQ from possibly drive test data or walk test data, what does your throughput look like, and ultimately how many users are in that particular area. And of course, with the pandemic, you have a lot of people working from home, as I am today, and you hear in the background some yard work taking place. So your traffic trends can change. And so being aware of where your traffic demands are, not only currently, but historically. And not only that, seasonally. This is football season. So definitely you see the traffic trends change on college campuses throughout the country. So not only do you need to be aware of the opportunities to analyze your KPIs from the traffic engineers with the network stats, but also tapping into crowdsourced data. That will also help you determine where your users are. Now, granted, crowdsourced data, network stats are not all encompassing. There are gaps that are created, even though it will help you with your analysis. But ultimately, you need to take into consideration not only those, but also customer complaints, and definitely don't discount the need for walk test data. But there are solutions that will help you encompass all of this in one solution, and we'll get to that shortly. But not only Traffic trends are important, but as you analyze this information, you will need to know where you can place those nodes for your outdoor DAS. Node count and placement will become key to your campus design, uh, making sure you're aware of the traffic trends, the key performance indicators, and the equipment type. What type of equipment will you be deploying on these outdoor nodes? That will help you determine whether or not you'll be able to place that equipment on a pole that exists, or a pole that will a new pole that will need to be deployed in order to house your equipment. Because with the growth of campus designs, you're seeing more and more outdoor nodes with multiple users on that particular pole. So you may find yourself needing to be in an area where other carriers have deployed a small cell, but there's no room on the pole. And so you may have to switch gears and look at a different pole placement. Now, trying to do this with a bucket test or CW test or transmitter test can be very time consuming and really create hardship for your team to analyze the best placement. And when that node has been selected and you have to look at a different location, maybe due to fiber not being along that same road that you originally want to place your node, or fiber being full at that particular location, and it is delayed until you can get fiber to that location, or there's no fiber available at all. So fiber is going to be a key play in your node count and node placement. So definitely being aware of those things, and not to mention the, or not forgetting to mention rather, the aesthetics or concealment or camouflaging your nodes. Some municipalities won't put restrictions because they see you as a utility provider, and you can put up the ugliest construction of parts and pieces and it looks like Frankenstein when it's done. Or they may be extremely conservative about the aesthetics and want you to place your pole to look like an existing light pole that's already there. And so those challenges will need to be considered during your campus design process, because you may be forced to move a node that was critical to your design, and you may need to be able to be flexible enough to adjust and understand the impact it will have not only on your outdoor design, but the impact it will have on your indoor design. And this leads me to the sector seams. Sector seams and handoffs will become a vital part of your customer experience when it comes to sector seams, because you're trying to provide coverage in a particular area. And as we mentioned earlier, that you already have pent up demand. The user's already there. They're just waiting on you to provide coverage, and which also will impact your capacity plan for the number of nodes that you're using. You may realize that you need to sectorize those nodes and use panels instead of a omni configuration for that node. And so a cantenna may not be your best option. You may need to put panels facing opposite directions and create seams or sectors in your plan. But making sure that those sectors have a balanced approach across your design, because it definitely will impact the call quality and throughput. You may be providing a small cell at a location that is going to provide offload from the macro network, but because you need to consider how much coverage is coming from that macro design, it could ultimately create a SINR issue or SNIR issue that will impact the call quality or the throughput quality because of the amount of RF energy in that area. So those things need to be taken in consideration, and to be intentional with your handoffs. You need to know where your handoffs are taking place and be able to control the handoff placement so that you can control the capacity and the quality of that user experience. So your handoffs, ingress and egress, you need to know where those will take place in reference to that macro environment. And your transition zones need to be balanced. Once again, where those handoffs are taking place, does it make sense? You shouldn't have a handoff that surprises you. You should know where those handoffs are taking place so that you can direct your traffic from one node or one sector to another. So some campus design scenarios to consider. Definitely the area of interest. You need to know the extent of that area and where the traffic is, the traffic trends and traffic pattern is in that particular area, because it will dictate the placement of the nodes. But not only that, customer complaints need to be considered. Now, customer complaints can be an afterthought when it comes to some campus venues, not necessarily campus together, but some campus venues like stadiums and arenas. Consideration for back office staff, news and TV crews, their broadcast areas for reporting purposes in that arena or that stadium. Even staging areas for performers and dressing rooms for those performers during off-peak season when there are concerts or other sports camps that are taking place. Even athletic dressing rooms and training rooms should be also considered in your analysis and targeted for your traffic impact, because we see that there are smartphone users everywhere. And so the impact of that data throughput can be, will be key to your customer experience. And it's better to consider this on the front end of the design process rather than an afterthought, and it will impact your overall system design and cost in the long run. So how to approach a design with no macro in place? Well, that piece is going to be much simpler when you don't have to consider the macro environment. So all you're really concerned about is possibly the in-building coverage. But there are some applications where you will only be able to provide that private LT or CBRS coverage from an outdoor perspective rather than an indoor perspective, or you may be able to do both. So considerations for taking into account the in-building system in conjunction with an outdoor ODAS for that CBRS network and private LTE or that private LTE network will definitely need to come into part of your consideration and your checklist as you move through your campus design. So when you look at a design with no macro in place for a private LTE network or CBRS, you need to be aware of the technology band and equipment that your OEM is providing, and whether or not that component or product has been modeled for design purposes. Of course, you're seeing multiple OEMs coming out with new equipment weekly now, new antennas, new radios, new configurations. And so being aware of that component's capabilities when it comes to the feature set, whether beam steering is available for MIMO, or whether or not in the IoT consideration, if that equipment is ready for configuring bandwidth parts, whether it's for an IoT scenario or general bandwidth coverage, low latency or high bandwidth demand. You need to be aware of those feature sets that are available for that equipment and how you will deploy it for whether it's going to be indoor and or outdoor. Now, serving that target traffic when it comes to using outdoor nodes only, you need to be aware of the penetration of that signal in building. Because we're talking about higher frequencies, many times with 3.5 gigahertz when it comes to a CBRS. You need to understand the impact not only of the signal into the building, but how much coverage you'll have and the quality that will be in the building, and what kind of devices will be on that network. And of course, the weak link is always the uplink. So definitely being able to understand the impact of that is going to be critical to your CBRS deployment or private LT deployment. And if you're using an indoor system only, it makes it a whole lot simpler to process this information. But you need to know if your in-building system is going to cover outside of your building, and if it will impact any other users or coverage concerns outside the building. Now, designing with an existing macro is definitely becoming commonplace. We see definitely the challenges that will be, we've already mentioned before, but some of the things that we don't always consider or that needs to be taken into consideration when you're designing your in-building system versus your ODAS system versus the macro is areas that require transitional area or gathering areas before an event, like tailgating areas or pre-game gatherings. And then, of course, you need to consider off-season campus events that may include concerts and even basketball camps, the sporting camps that take place on different campuses. But in cases where you're talking about a business, that may not be as much of a concern where events are seasonal. But definitely the determination and awareness of coverage and its impact needs to be considered when it comes to determining the ODAS, dominance over the macro coverage, making sure that your traffic is being offloaded where you intend it to be, determining the IDAS, dominance over the ODAS when you're working with all three, a macro, ODAS, and IDAS. And then determining the IDAS addresses all the targets needs within the facility without over designing or under designing that IDAS. So with all of that being said, here's your solution, IB Wave Reach. And so we'll take a scenario where we'll look at a couple of opportunities where we'll address from scratch a area where you don't have where you have a campus environment, but you don't have geodata readily available for you. So let's switch over to Reach now, and we'll look at an area that we know. Since I'm in Arkansas, I'll take advantage of bragging on my team, the Arkansas Razorbacks, and they're undefeated so far, 3-0. I know that's a little premature, but I'm bragging anyway. But let's take a look at the University of Arkansas's campus. So when you open up Reach and you don't select Geodata, it will give you this OpenStreetMaps map of the globe. And so what we'll like to do now is move to a particular area and focus on the University of Arkansas, and that's located in Fayetteville. So we'll look that area up and we'll see that the map OpenStreetMaps is readily available and brings this area up. But we currently, when you do this, you don't have terrain, you don't have 3D buildings and trees, you don't have the clutter classes that we mentioned earlier that will be critical in your design. And so one of the things that we mentioned earlier is that you don't need the whole state or the whole region for your geodata, although you can import geodata from other tools that you may have, macro design tools that you already have at your disposal. But in cases where you don't have that geodata readily available, you can get free geodata. So let's quickly look at this particular area and how much area will be required. So if we outline this campus, you'll see that it is only less than 1.5 square kilometers. So you're not looking at a large area of geodata, but this is, on an average college campus. You may have some that are 2 or 3 square kilometers, but sourcing this geodata can be difficult when you're looking for free geodata and scouring the extents of the internet. So let's look at one way to do it using Reach. So there is an extension that's available where you can bring in the terrain for this area, even 25-meter terrain data. In some cases, you may be able to find terrain data as low as 5 meter. So that will be some investigation that will need to take place, but you have some options to select input data, and then the output for this particular area we have as low as 25 meters for resolution here. So I've already brought that in so you can see the 25-meter terrain data for this area. Not only that, we can bring in back under the extensions tab using OpenStreetMaps. We can bring in buildings. Now here's where you can find a challenge. The challenge is, will the building polygons be all the buildings in the area I'm concerned about? And if they are, what height have, and a lot of times when you're talking about OpenStreetMaps, the height may not necessarily be available. So this can be in some metropolitan areas, you'll see uh, plenty of coverage with those buildings, but not necessarily the height. But you can determine a default height for those buildings, for each floor level being 4 meters, and a default height for the building of 10 meters. And so we'll say, okay, and I've already downloaded those buildings for this area. We'll turn those back on. There's OpenStreetMaps, and here's the buildings for this particular area. So I was excited to see that there are plenty of buildings here, but unfortunately, there's no trees on this campus. Well, if we turn on the Bing maps, we'll see that there are plenty of trees on this campus. So this is where you will be a challenge with creating trees. Now you can create custom trees and foliage in Reach, but of course it becomes very time consuming to create that when you have a lot of trees. So there's some things that you can do to manage that. But not only do you have the challenge of the buildings being or the trees not being there, but in this case, if we look at it in 3D, you'll see that the buildings have all the same height. Now, the terrain is taken into consideration, so you'll see the difference in the terrain and the elevation with the different buildings based on the terrain height that we imported in. But unfortunately, all the buildings have the same height. So if we switch back over to Google and Google Earth, you'll note that when we, oops, too far. You'll note that when we look at the different heights of those buildings on campus, that those buildings are not all the same height, clearly, obviously. And so the challenge is now your buildings of concern. Are those buildings that you're concerned about? Do you have design plans for those buildings? And if you know the surrounding buildings that will be impacted by your ODS design or your macro design, if you know the height of those buildings. So if you can manually make those adjustments in the table for those buildings. So you can make those adjustments and change the heights. And of course, you can see all the heights are the same here. You see some that are lower, but mainly most of those are the same. And so you can manually make those changes based on that table there and for the OSM buildings. But in cases where you don't have the geodata required, the clutter that is going to be determined based on that geodata, because there are areas where you have not only buildings and trees, but also other type of vegetation that may not be captured. The benefit of having that will definitely bring more accuracy to your design. So in cases where you're focusing on a few buildings in an area where the number of trees is minimal and you're not really concerned about the number of trees in this particular area and you can manually draw those in, then in cases like this, free geodata may serve your purposes fine. But in cases where you're looking at a larger campus area and you need to be aware of the impact of those, the foliage, the vegetation, the different building heights, and you don't have that information readily available, and of course, you can purchase geodata. And let's switch to an example where we have purchased geodata and the impact that it will have on your design. So in this case, this is another campus, and we have 2-meter geodata that has been sourced from LuxCarta. We have terrain height, 2-meter terrain, 2-meter clutter. We also have 3D buildings and trees. So we can turn each layer off for the trees. We can turn the layer off for the buildings. And you can see small cells already deployed, ODAS, small cells already deployed throughout the campus. You see some macro sites already serving the campus. Well, let's turn on the small cell coverage, RSRP coverage, from those small cells, not considering the buildings and the terrain. So just by not considering the clutter, but just the terrain and the height of the small cells serving this area, looks like you would have great coverage on this campus. But when you take into consideration the buildings, the trees, the clutter associated with this area, you see a much different picture. So let's turn back on those buildings and trees. And this is a great way to do analysis for challenges where you may have seasonal foliage, where you want to determine coverage where how much coverage you'll see from your macro or your small cell deployment or your ODS deployment when the trees are off, the leaves are off the trees with the fall and the winter. And then you see the impact of those trees when the leaves are back on. And of course, you can also see building penetration from the coverage from those 3D buildings. Now, there is a 10 dB default building loss already built into Reach when you're looking from this perspective. But you won't know the true impact of that building penetration until you analyze not only the outer walls for this building, but also the inner walls and materials associated with this building. So let's take a step back. Let's go a little further back. And let's consider this environment based on the macro coverage. So one of the things that will definitely be helpful when you're doing your outdoor analysis is to be able to determine not only the coverage from your macro environment, but at different frequency technologies. So at 700, you may have great coverage, but when you look at your area or your campus from 2100 megahertz or 3.5 gigahertz, you may see that you don't have the same level of coverage and quality expected. In this case, we're looking at RSRP for 2100, and you see the impact of the coverage, not only from your macro environment, but the surrounding buildings. So in order to enhance the coverage for this area, and you may have taken into account all the recommendations for your network traffic team and looked at the network impact, crowdsourcing data, as well as customer complaints, and have identified there are 4 buildings on this campus that need to be considered for not only the ODS coverage for your pedestrian traffic and offloading the macro environment, but also whether or not you will need in-building coverage for those buildings. So what we'll do is we'll turn on the outdoor coverage for this particular, those small cells. And you'll note that in this case, you have 2 small cells on either end of the building focused on this outdoor environment. But what you would need to determine is, how does that interact with my macro environment that's already in play? And you can determine that by looking at SINAR. Will this impact my coverage and quality, even though I know it's going to improve my coverage, but what will the quality look like? And so in this case, you'll see that you'll have some SINAR issues in this particular area, and definitely you may want to consider moving this particular node because of the impact from the macro coverage of this site. So we can look at the best server and determine which macro sites are getting in there and serving this particular area. And so in this case, you see this sector serving here. So you may be able to make adjustments to the macro environment or just your small cell placement. Now, the good thing about doing your campus design from this perspective is that you can move those nodes as needed and say, I want to move it here in this particular area outside of that coverage. And so when you move that small cell, we'll move it again. Let's try that again. Let's see, let's try that one more time. Okay, I've got a glitch that's not cooperating with me here, but that's okay. We can keep moving. So the idea is to be able to move that small cell to a new location, rerun the analysis, and verify that your SINAR is no longer an issue for that particular area, and that you can still serve the offloading of the coverage as well as the building penetration that you need from this outdoor small cell. So let's move into a scenario where we have 2 small cells serving this particular building. And this is our recreation center. And what we'll do is look at the coverage penetration from these 2 small cells. And you see that definitely in this particular area on the backside of the building, that you will have some coverage issues. And you see how quickly the coverage fades in this area. But this is just taking that 10 dB loss into account from this outer polygon of the building. And what we can do is switch now to our IBWave design solution to see the impact of this small cell deployment on the in-building system. And so you'll note that this building, each floor has a different square footage. And so we'll want to take into account the floor with the largest square footage for the building polygon that you see in Reach. Not only that, you'll want to understand the impact of this design for this particular building, and we'll look at it in 3D. And you'll note that there's some interesting architectural challenges that need to be you need to be aware of. So like in this particular portion of the building, you have a closed walkway, but on these two floors, you have an open air walkway that will be impacted by the macro environment. And then this portion of the building, you have some low-E glass, as well as some concrete columns on the exterior of this portion of the building, and overhang from this portion of the building. And then we have some really interesting sawtooth architecture from the glass and concrete part of this particular area on this floor of the building. So those things need to be considered when you're doing your in-building design and taking into account the macro environment. So one of the great things about using Reach, you can import the predictions for IBWave Reach and associate that with the different network frequencies for the macro environment versus the in-building environment. And you can make those, by chance it does not make that association, you can manually make those associations and then import that macro environment as those outdoor small cells or ODAS nodes come in as interfering sectors. And you'll see each floor has the associated outdoor signal at that particular level. Now, you don't necessarily need to know the different floor height, is just as long as you accommodate the total floor structure in Reach. But you'll note that this particular floor is below ground, so your imported and your interpolated signal won't be taken into consideration. So as we look at the Reach imported data, you'll notice that we have an outdoor tab in our panels to the right. You can select the imported signal and you'll see the impact of that, those two nodes that are on either end of the building, but you'll see that you have several PCIs that are encompassed in the area or impact the area for this particular building. So you can actually select one PCI to see its impact for this building. And so that's PCI 139, and you can see it's coming from this side of the building and its penetration, or you can do multiple PCIs. Let's pick this one. And so we can see that we have those two small cells, but not only those two small cells that are impacting this area, we have some other small cells that are also impacting the area. And let's just pick 391, and we'll see the level of impact. So you see that coverage from small cell 391, but we really want to know what this impact is like, taking into account the in-building, not only the exterior walls, but also the interior material associated with this building. So we'll quickly switch over to the predictions tab. We'll use the interpolated signal, although you'll use a multiplicity of output maps for your in-building design. We'll only look at 3 output maps for the impact of the macro environment versus the impact of the indoor system on the macro environment. So we'll look at the interpolated signal from the outdoor environment. So that looks much more pessimistic compared to what we saw with that only 10 dB default loss from that was imported. And so we see the impact of these concrete columns and the shadowing from effect from those inside the building, as well as the refraction of the signal coming in. Of course, the other degraded signal as it impacts other portions of the building. As you look at different floors, of course, below ground floor, we are not importing or interpolating signal below ground because the coverage is going to be so weak it won't matter. But as we look at other floors, you'll see the impact of the coverage based on the building's design. even that sawtooth architecture on the fourth floor. But as we dive quickly into other aspects of this design, whether we're placing our nodes to cover this particular portion of the building, because this is open air to a swimming pool below ground. This is open air to racquetball courts below ground. But we see the placement of our small cells to serve this area. Let's quickly look at signal leakage. How much of these small cells are covering outside the building and will also impact our handoff ingress and egress coverage. So we see this small cell getting outside here. We see small cells from the floor above this floor getting outside here. And so we want to make sure we are addressing the impact of this in-building system on the macro. Well, what about the macro's coverage on this in-building system? So we see this area is really good, except for, of course, this is open air to the swimming pool below. We're not concerned about that. This is open air to the racquetball courts below. We're not concerned about that. But this entryway, the macro environment is still the dominant server in this entryway, and we will have some handoff challenges in this particular area as well, even some coverage concerns, our quality concerns. And so those things you need to be aware of when you look at each floor and the placement of those components and the impact of that macro environment. So let's go back to, let's quickly look at exporting. And when you export those output maps, there are only 3 that are required to integrate the in-building system with the macro environment. That's the LTRSRP map, and when you select it, it automatically selects in the background the interpolation map and the signal leakage map. And as we switch back over to Reach, you'll see the impact of those. So let's do a before and after view, and we'll clone this location. We'll set them side by side. And let's sync those maps. So when I adjust one, the other will adjust the same. So in this case, we're looking at the Recreation Center, and this is our before view. This will be our after view with the impact of this in-building system coverage in comparison to the macro. So let's turn on the RSRP map, and now you'll see the coverage from those small cells on this particular floor, as well as that shadowing effect that we saw from the columns outside the building, that open air coverage and this open air coverage. So you see the impact of that. But you also see the signal leakage that we were concerned about from this particular area, and we have some signal leakage from the floors above in this particular area. But the only way to truly determine what that impact is if we look at the best server view. So let's look at the best server for the macro environment, and you'll see small cell 9 serving the majority of this portion of the building, small cell 8 getting in here, and small cell 7 getting in this portion of the building. And so if you are not aware of that small cell serving in this, inside the building, that could definitely impact and be a missing neighbor when you set up your neighbor list for the in-building system. Well, let's see what that in-building system looks like with the best server turned on. So as we look at the best server, we'll see that the best server is the in-building system. We see that shadowing effect here from the columns, but we also see that our in-building system is serving outside the building. So this will definitely impact your handoff ingress and egress, as well as your capacity plan for this in-building system. Not only is it serving inside the building, but this street outside, as well as this parking deck. And as I mentioned before, we also see small cell 7 as a neighbor to this in-building system, with it serving outside the building, and it can become a missing neighbor and cause drop calls as well as poor throughput and poor call quality. And of course, the fun part of this is seeing this in 3D, and we'll quickly show you this. As we saw in the first example of a campus environment, we saw that with no cluttered data and trees associated with the 3D buildings, but we'll look at this particular building project, or this campus project rather, and let's look at the RSRP coverage, and let's pull up the 3D viewer, And not only will we include the buildings, but also the network, which will be the macro and the small cells. And we'll see also the 3D buildings and trees. As we quickly bring this up, we'll see not only the coverage, but the impact of the terrain, heights, as well as the building heights as well associated with this campus. So we'll zoom in. So you can already see the difference in heights in the building. You can see the trees, but we also mentioned the network. And so let's quickly turn on those sites. So you can see the small cells that are surrounded on the campus. You can also see them glowing over in the other buildings for the macro sites. And we'll turn that off and we'll refresh this with our SRP map. So you can see the coverage in 3D. And so now you can see that coverage, not only from those small cells outside the building, but also the penetration that we talked about from this in-building system, as well as the penetration of the surrounding buildings. Of course, we can see this in multiple layers. If we want to turn on multiple floors, we could do that as well. But I want to take time to make sure we capture any questions. And I know I covered a whole lot in a short amount of time. So Kelly, did we get any questions from our listening audience today?
We did. Thanks, Robin. I'll get to them. More importantly, you got a few other Razorback fans here also saying "Go Razorback," so you're not alone.
Woo pig suey.
All right. In terms of questions, so one is how to identify where the ingress egress takes place.
Excellent question. So you can do that a couple of ways. One by, as I mentioned, showing the best server to see where your best server is located, but you also can show, we could do an analysis, and I didn't bring one up for this particular one, but I did for the macro environment. You can also see from Sinar where, I didn't do that for this particular area. This is pre the system being deployed. So you can see the impact of where some of your handoffs will take place based on Sinar. So the call quality, our data quality of that coverage area versus the handoff or best server will assist you in determining where those handoffs will take place. So of course you can see the best server from this view and be able to note if you have any potential missing neighbors from your design. Great question.
Okay, great, thank you. One question is, can you show the project in Google Earth?
Absolutely. So you may have noticed when I clicked on Analyze and selected the 3D viewer, there is a Google Earth export option. So you can actually export this project to Google Earth. And this is usually a common question that I get from time to time. So I believe I have Google Earth open already. I do, and I just need to bring it over here. So you can actually see the project now in Google Earth. And we'll zoom in. And you see the 3D buildings and trees. Normally, if we turn those off, you will see the normal Google Earth buildings, but they're not outlined in this white outer highlight for those buildings. But there's our interesting building that we've been playing with today, as well as the small cells that we mentioned and the trees that we also mentioned. So you also see some construction taking place in buildings. So this is a great tool to help you with greenfield projects, where if you don't have the building already built, but you have the design plans, you have the project, you can design this building in a greenfield environment and create the project in Google Earth and share it with your customers, see kind of the coverage and impact of that building. And speaking of impact, let's show very quickly, let's show the RSRP. I think I brought this in as pre-canned. It may have shown up better if I just exported it directly. So that's an operator error in my case. Yes, I should have. It'll work better if I had directly exported that, and so we'll do that anyway. And while I'm doing this, go ahead to the next question, Kelly.
Sure. One question is, I think at the demo you're giving, why small cells have good SNIR?
Great question. So when you're looking at small cells, they're traditionally are closer to the ground, closer to your user, as well as more of them. So you will generally see better SNIR associated with those small cells in your deployment area. Now, the challenge that you will have is when you're deploying small cells in a macro environment, in an ODAS environment, where you have pretty good coverage from the macro site. So in cases like that, you run into challenges where that macro environment could potentially, and so now you see the coverage maps that I was referring to when I brought that in directly instead of that CAN view that I was trying to show you. All right, so that makes that a little more fun when you can see it happen in real time.
Oh, that was fun.
And so definitely want to be concerned about placing those small cells in already good coverage area with the macro site or sector serving that area. That can increase your SINAR. And so those considerations need to be taken into your account when you do your design, because you may need to make augment to the sector orientation or down tilt or placement of the outdoor small cell.
Okay, great. How do you actually get geodata? What are the options?
Fantastic question. And so what we did in this case, we actually sourced this geodata from Luxcarta, and this is 2-meter geodata for terrain, clutter, as well as 3D buildings and trees. Now, of course, there are multiple sources for geodata sourcing. InfoVista, you may have a macro design tool that you may already have geodata like Atoll or Planet, and that can be imported in as well. And in cases where you don't have that are readily available, we are more than happy to help you acquire. We can source that for you. So to make the import process smooth and easy, it is readily digestible for your project. So we try to make the project integration process easy for you.
And maybe a related question, but it's what type of data would crowdsourcing provide?
Generally, crowdsourcing data comes from Twitter. It was actually the first crowdsourcing source to be integrated with macro design tools. And of course, when it was early introduced, Twitter was still new, but it was easily to access that data. You could see the user's signal strength. You could see the quality of the call. You could see the area. Not only the location, but even the elevation associated with that. So it was really nice to bring that information in to help you determine your hotspots. Of course, everybody's not on Twitter. And so the challenge is, take that with a grain of salt. It's just another key indicator for areas of concern. But definitely don't limit yourself to one source, because you want to be have as much court awareness, our campus awareness, for your design as possible.
Okay, great. And maybe just one last question here, but is it possible to do both 5GNR and CBRS in what you're showing in reach and design?
Excellent question. So what I would like to share with you now is the fact that you can switch but you can add different technologies. So you can, in this case, I've got LTE here, as well as some Wi-Fi nodes that I didn't share with you, but also you can bring in your 5G NR and create that network. If you already have that deployed in another tool, you can import that information in. Of course, you can also use CBRS data, 3.5 gigahertz for private LTE, even LoRa. So you're not limited to the scenario I gave you here. And of course, in design, you have that capability to create those other wireless services. So under properties, you'll see that you can bring in multiple wireless services that will address your design needs. So whether it's 3.5 or what have you, for 5G NR, you will be able to set your block as well as your numerology and bandwidth parts associated with that design. Of course, you definitely need to take into account whether or not the OEM is implementing those feature sets and how you'll deploy that in your design.
Right, makes sense. Okay, so that brings us to the hour. So we're going to stop the webinar here. A big thanks to you, Robin, for doing the webinar. Really appreciate you putting it together and sharing your expertise with everyone, and a bigger thank you to everyone who joined us for today's webinar. We will be sending out a recording afterwards, so you can look for that in your email. Thanks very much and have a great day.